Sampling. When you consider where you're going to collect your data, you need to consider your sampling strategy and how many data sets you require based on your statistics that you're going to undertake in your analysis. So if you've got your transect laid out, you've decided your line that you're going to follow, or you've got an area that you're going to use, how are you going to choose where along that line or where in that area you are going to place your quadrat? Now, there's three methods of collecting your data, your sampling methods. You could do it randomly, you could do it systematically, or you could do it stratified. Now, mostly you will use a combination of those, because if you're going to just be systematic and follow it along your line, you may miss out important things. For example, if you're collecting data along a transect and you are just doing it directly below the tape measure, that's a very small area that you're going to be measuring. You can turn that into a belt transect by making sure that you do maybe both sides of your tape. So put a quadrat one side and a quadrat the other side. You've turned your point along a transect into a belt. Again, that's going to be determined by where your tape measure is, and of course your locations along it probably are going to be systematic. You may suggest doing it every 50 meters or every 10 meters. However, you may think that you're missing things with those distances. So if you're finding that 10 meters is too far, or usually it's okay, but there's suddenly something interesting in between it, you may want to use opportunistic sampling when you put in extra ones based on something important to do with your data collecting. So systematic will make sure that you cover every 10 meters or whatever you're going to be measuring in the distances between it, but you may add in some opportunistic. Problems with being systematic along a belt transect, you are only doing a very narrow area of this whole sand dune system. To broaden that out, you may use your transect, but do random sampling to locate within those areas. So we've done a transect here, but within this zone here, it's almost like stratified sampling. So this is one area. Within this location, we are going to do some random sampling. Now, your random sampling is you placing this somewhere that you don't choose. And you can do that by random number generating on your phone and either saying the first two numbers, you're just going to walk left one direction, that many numbers of paces, and right another way to find that location. Or you could look at your phone contacts, get the two last numbers from the last person you phoned, and you can measure 2 meters in an easterly and 2 meters in a southerly direction and use that as your location. It's random, so it's got issues. You might end up going in a place which is not representative of your area, which is what you're trying to find in your location, but it does mean you're not being biased in your data collecting as well. Systematic means that you do not choose exactly the location. Your tape measure will tell you the exact location, so you follow that line till you get to how many meters you're going to, place your quadrat down, and that is your location. Stratified sampling is if we're going to be using an area and we have to undertake random sampling within that. You can't just do stratified sampling when you're doing physical data collecting or quantitative data collecting. You need to do some other point. You need a point location, not just an area. So think of those three things to do with your location inside your question as well. We'll look at those when we go through generating your data. The next important thing is how many. So deciding where your sampling sites are going to be will obviously be determined by how many you need. Too few and you won't be able to do the stats that you need for analysis. Too many, you'll have too much data. You might miss trends because there's so much information there, and it will start getting very hard to get through all that data. So look at your statistics. Your statistics will tell you need 12 samples or 12 pairs for your t-test, or whatever test you're doing, there will always be a number there. Use that as your guide. If you don't know that before you come on site, you won't get the amount of data you require. Distances between them, again, that might be something that you vary when you come on site. You may decide to do it every 10 meters. You come on site and you think, nope, that's too far or too long, or I can't do that many, I haven't got enough time, so you might change it. So think about that as well. Plan one way, but be adaptable when you come in the field and see it, and think, is this going to work in the time frame that I've got? Do I have enough data without doing all of them? am I actually going too far? For example, if you're going to look at human impact, is there really much point in going way, way, way past all of the paths where people aren't going, because there won't be any human impact? If you're going to be doing vegetation surveying, you really need to have a quadrat. A quadrat provides you with an accurate sample size that you're going to use for all of your sample locations. The sample size is very important, and it's dependent on the size of the species that you're probably going to be finding in that habitat. If you're going to do a woodland, you need 25 by 25 metres. Inside a sand dune system, a 1/2 metre by 1/2 metre is the appropriate size for the type of species we have here. These quadrats here are called frame quadrats because they are a square shape which is in a frame. And this frame here is called an open quadrat because it's just that 1/2 metre square. You can also have ones which have got dividers in them, and depending on how much detail you want inside it, you can have it divided into 25 or divided into 100 squares. Now this helps you to judge the percentage cover of your species. So if you are measuring percentage cover, you might want to consider getting one which has got lots of squares. For percentage cover, in order to measure percentage cover in this open frame, then it's a lot of judgment by eye. So we would have to guess how much this marram grass here was covering of this open square. However, if we look at this square, we know that each of these is 4%. So if one of those squares is completely full of a plant, like this one here is half full of rest harrow, we could say it's got 2% rest harrow. However, if we use this one here, we can see that lots of these are completely filled with some things like this grass here, so that's 1%. We can then add up how many. However, if you look at these, we have a problem, especially with the one with a high number of squares. If you look at the open one, you can see all the plants are poking through, and we can see as they're sitting in situ, their percentage cover. When you get to this one, however, lots of these plants have now been squashed by our quadrat, and they're now leaning over the squares. So if you're judging that by percentage cover when you've got the quadrat on top of it, you may say that each of these is filled with this marram grass. But actually, when it's standing upright, if you thread it through, it's probably only taking up one of those squares. So you need to be careful to make sure you use the right piece of equipment so you don't change your data because the actual equipment is changing the lie of your vegetation. Problems with doing percentage cover is that if you are measuring percentage cover and you have a plant that just is a big plant that grows widely, like a broadleaf, like this plant here, this dewberry is always going to take up more space, even if there's just one individual plant, than something that is small, like a grass. So you will overestimate the percentage cover of the big plants and underestimate the percentage cover of the smaller surface area plants. So it's not ideal. Also, of course, it's all about your judgment. Even if you are trying to say that each one of these is 1%, there is still human error involved. So trying to have a couple of people's points of view to discuss whether you agree on the percentage cover helps, but also adds to the amount of time it takes for you to measure this. So percentage cover, remember percentage cover, you're looking at a 2D shape, but in fact this environment is 3-dimensional. So if you don't push behind the vegetation that's at the top and look underneath, you might miss important key species. And also, when you add all that up, you could get up to 1,000% because, of course, it's completely 3-dimensional. So do be careful you're not missing something because it's been covered up by a larger and more obvious plant that's above it. The other thing you could measure using your quadrats is the density of the plants. So if you're looking at density, we're actually going to count how many individuals there are within your quadrat. So you're literally going to count how many plants there are, how many individuals of the individual species. Now, if you just think about that for a minute, if we're talking about blades of grass, if you're counting individual blades of grass inside your quadrat, that's an awfully long time you're going to be spending on each quadrat. And why? Why do you need to know the number of individuals? So you probably are not going to be wanting to measure density because the chances are human impact on density is very difficult to see what the what the relationship is. You're probably much more likely to want to know about frequency, so whether something is present or not, or maybe just the number of different individuals. So that is the actual species diversity. So using those key terms is vital to work out your methodology, but also to make sure your data is actually going to provide you with some reliable data that you can look at and analyse properly. To try and reduce the human error going into the percentage cover data collection technique, there is a couple of scales that you can use. There's the ACFOR and the Domin scale. Each of those provides a scale for some percentage covers. So the ACFOR scale provides you with categories for different amounts of percentage cover. So you will have abundant species, common, frequent, occasional and rare, and they actually identify the ranges of percentage cover. So in this quadrat here, all this fescue grass here, there's a lot of that. It might add up to say 80%. If it does, that's probably abundant. Whereas the marram grass, this is only a 1%, that's probably occasional or rare. These also give you, the domain scale especially, some numbers that you can use to take into account things that are outside of your quadrat but are still present, because it's tempting to look at something that's outside and put it into your quadrat because you've missed it, because of course the relocation of your quadrat is quite random really. So thinking about how you're going to make sure that you cover everything inside your quadrat and you're getting the information that you require to answer your question is vital. The other thing you can measure is the frequency, and that's the percentage chance of you finding an individual species inside a sample area. So you need to do a number of quadrats for that. So you need quite a high number because you're working out a percentage over those individual quadrats. But it's very fast. So you pick your species or you pick your species list, you look at your quadrat, and if it's present, then that's a tick. So it is present. It's just a yes or a no. And then after you've done 10 quadrats in one area, you can work out a percentage of chance of finding that individual type of flower or plant. So that's the frequency. However, if you want to be more precise, the size of the quadrat is really important when you're measuring frequency. The larger the quadrat, then the less reliable your data is. So you need to shrink it down to make sure it is the right size. As I said before, these ½ meter squared are the right size for frequency data. But if you want your data to be pinpoint precision, you need to go for a point quadrat. So this quadrat here reduces the size from ½ meter to the point of a needle. So this point quadrat, this is 10 quadrats we have in this point frame. So you take your needle, you place the needle through the frame. What you do is you actually see if it touches the species that you're looking for. And when it does touch it, then that's a frequency of 1. You then repeat it with all the other needles across there and you get 10, and you see what the frequency is across that 10. Now, that's just one species you'll do that for, and then you'll have to do it again for a different species. We use these usually in biology A level, not usually geography, because you really shouldn't necessarily need that precision of frequency data. So if it's something is present or not, the frame quadrat is probably more suitable for you to do that. But think about the numbers you need to do. Consider your statistical analysis you will need to do and the minimum number of data sets you need for that. One of the other issues you will have in the field is you have to identify your species, or do you? So I can tell you that we've got some dewberry here, which has got some thorns on it. It's also got some berries that you'll see. You've got some rest taro here, which feels like suede. You've got some plantain here, which has got long stripy leaves. You've got your marram grass here, which is curled up, and you've got some red fescue as well here, the grass. But do you need to know the names of the species? Think about your question, your sub-questions. If it's species diversity you're thinking about, you may just need to say how many there are. If you need to identify them, you need to be aware that that is going to take time, but you will get quicker the more you do it. One form of quantitative data collection you might want to take place in your data is some topography. Now, you aren't going to do this unless it's related directly to one of your sub-questions, or it's going to contribute to your data so that you can use it to analyse. It probably won't be necessarily the primary bit of information you're gathering. It might be some supportive information, but you need to make sure that it is relevant and it is going to provide you with data. Because it's time consuming, it requires at least 2 people. So we will have just 2 people. So think about it and think of it relates to one of your sub-questions. So topography, what we're talking about is the slope of the angle of our sand dune system. Obviously, if you think about a sand dune system, you're going to have changes in slope, and that will give you a cross section of the whole of your succession. So Dylan, we're thinking more about you because of the successional side of it is going to provide you with that change over your transect. Probably the best place to do the topography that have been impacted by humans is at the embryo dunes. So here, right close to the car park, if we do the angle here, we can have a look and see if it's how steep it is. Then if we repeat that at a transect further away from the car park, we can see if those people actually sitting at the back of the beach are actually decreasing or increasing this angle, and that would be a significant impact of humans on the topography of the sand dune system. If you start doing this for the whole of your transect, you need to think very hard as to whether that's a realistic thing to do. Is that going to be impacted by humans? Are they actually going to change the shape of the sand dunes further than the beach itself? Probably not, because you've got vegetation there holding it together with the roots. So consider where you need to do this. Is it just enough to do the embryo dunes? If you want to measure the topography of your sand dune system, you need 2 ranging poles and a clinometer and a tape measure. If you have another person you're working with, they need to stand at the other pole. You need to locate your first pole where you are starting your transect, so either on the strand line or at the back of the beach, wherever you consider the start of your transect to be. And then your partner needs to take the ranging pole to where the change of slope is. So we could have actually placed that ranging pole at the bottom of that marram grass there, because there is a change in the angle there. So we could actually do this in 2 sections, but I'm just going to show you here. We need to make sure that our ranging pole's at the same depth in the sand. So I've gone up to the metal bit, on the same on the other pole. It needs to be, make sure that it's vertical and not on a slope. And if your partner at the top can hold their finger pointing to the transition place between the red and the white stripes, it helps you to focus in with the clinometer. Lay out a tape measure between the 2 poles so you can see the distance between the 2. Then you can either use a gun clinometer or one that you just look through. You need to line up your 2 points there with the transition between the white and the red, and then your eye to the same point on the other pole. You then let go of the trigger and the wheel should spin, and when it spins it changes the angle. And then you need to check to make sure that you're following where it says read here, and it will tell you the angle. So look through, put your sighting up, same point on the other pole, let go, let it spin, release the trigger so it holds it, read off the angle there. That's the gun clinometer. Or you can use the one that you look through. Make sure you look through the small end going big, line up the line that's at the centre of it with the same place here, look through. If you can keep both eyes open, it helps, because you can see the pole with one eye, and you can see the dial on the inside, but you should be able to see the pole through the viewfinder, and then you'll see the numbers there of the degrees. Now make sure that you are writing down plus or minus, because it's going to be a positive angle because we're going uphill, minus if you're going downhill. And then you can see it's about 18 degrees. Now, if you've got more than 2 people, it's really handy if you can have somebody checking you on this dial here while you're doing it. Don't do it just once, repeat it at least 3 times, and then you can calculate an average. We then need to calculate the distance, measure the distance between the 2 poles, and that's your information. And you can then graph that to show the angle of this part of the dunes. If you want to do the angle from the whole of your transect, you then need to take this pole and move it to the next change in slope, go up to that pole and do the same measurement, and this time it will probably be a negative number. And you should keep doing that at every change of slope if you want to get the topography of your complete transect. Think about how many times you need to do that, if it's up, down, up, down, up, down, how long that's going to take, and if all that information is necessary to answer your question. It may not be, you may just want to have one little part of it. When you're thinking about human impact, you need to consider what the significant impacts actually are. So if you're thinking about the rubbish and the dog mess and the fireplaces, you need to think of a way of actually monitoring those and sampling those, because they will not be along a line. Obviously, one of the biggest impacts is going to be on the vegetation itself, but also it's the erosion being created by that footfall. So looking at the paths themselves will provide you with lots of data as how many people have been walking through it. The impact is going to be erosional laterally, so we can look at the width of the paths, making sure that they haven't changed, or see how they change as you get further away from the source of the people, so the car park. Or you can think about the vertical erosion, so we could measure how much soil or sand has actually been lost. So if we make a line and keep it straight, we can actually measure how much depth there is missing sand, and we can actually work out how much sand has been eroded that way. We can also do percentage cover. So again, using our quadrats, we could see around the path, next to it or on it, we can look at how much soil has been exposed due to the people walking on it. But again, it's not just the vegetation cover that's destroyed, you've also got changes in the soil, especially changes to its compaction. So we could measure compaction, you just need to drop an object that's pointy, and when it hits the ground, you measure how far it's gone down, obviously from the set height, and the further it goes down, the less compact it is. Things like compaction impact things like infiltration. So with infiltration, we can measure by pouring water into the soil and then counting and timing how long it takes for the water to actually infiltrate into it. If it's compact, then it would infiltrate much slower than if it's not compact. So these are all additional bits of information which will help you to understand the impact that humans are having on the area. Another useful one, of course, is the height of the vegetation. So it could be the height just to the side of your path or in your path, or it could be where you've got somewhere where you've got high footfall. Is there a change in height of vegetation? But you can't reliably use this as one set of data to compare, because of course the species will determine how high it is as well. But if you're looking at it along a path or at certain points in your transect, you could use your height of your plants as well. The other thing you might want to do along your transect is log how many paths there actually are. The more paths there are, so the actual proportion of paths in your area and your transect, that's quite easy and quick to measure. You just walk the transect and clock them. You can then compare that to somewhere further away from the footfall. So the density of your footpaths. So things to remember when doing a methodology for your data collection. What your question and your sub-question is. What are the variables that actually help you to answer that question? What type of sampling technique are you going to use, and why is it the most appropriate use? Where are you going to collect your data from? So your location. If you're going to do a transect, where will it start? Where will it end? What type of sampling you're going to use, and what are the intervals between your sampling locations? How many repeats are you going to do at each of those sampling locations? And is that enough for you to undertake the statistics that you require? So what stats do you plan to do, and what restrictions does that put on the numbers that you need for your data collecting? If you then think you know where you're going to go and what you're going to collect, make sure that it's feasible in the time frame. So you may want to collect this much data, but is it physically possible? If it's not, are you doing too many transects? Are you doing too many locations? Is your question too broad? Can you narrow it in and make it more focused? Can you reduce the variables? Can reduce the number of sub-questions so that you're actually identifying just 2 or 3 really precise and focused data collection techniques and trying to relate them to something like distance?